Well, welcome to a little video showing the 2-inch scale Burrell Scenic Showmans Engine that we've recently recommissioned for a customer, and the customer is new to miniature steam and therefore asked for a full guide to his engine, a how-to really on how to steam it up and how to run it and what all the controls do. So, starting at the beginning, this is how to put the grate in. There's a little bar across at the back in the firebox and across the front. So you saw I threaded the grate into the back first and then up and over and drop down onto that rail that you can see. Dead straightforward. The ash pan has a little flap at the back that you can see I was just sliding in there and then pushing upwards onto the two little pins. And the pins have little holes, and there's a wire clip that goes straight through those two little holes to hold it up. Quite straightforward, if a little bit fiddly. There's one on either side, so this is the one on the left-hand side of the engine, and then the one on the right-hand side follows. This is the damper lever going through to the damper door on the front, just slots onto a little pin there. That obviously attaches the top part of the engine to the ash pan, so it needs to be added and removed when you take the ash pan off. To free up the ash pan really, you can see the damper door working there. Putting water into the boiler now. This is Mark pushing a rubber hose onto the bottom of the blowdown valve, which is on the front of the firebox underneath, just in front of the ash pan where we were just dealing with. It's just a hose, the other end's connected to the mains, so when he turns the water on, the blowdown valve's open, you'll see the water goes straight through that valve. It's important to let the air out of the boiler, and this is the valve that controls the steam for the injector. All that does is just lets the air get out of the way when the water's trying to go in. This is just another example of how to put water in. This is the clack valve on the side. You can take the top off that, and then that's a direct route into the boiler, which Finn was filling with the funnel there. The fire next. This is charcoal, lumpwood charcoal broken up, soaked in paraffin. We're just pushing some into the firebox so that there's a bed of charcoal in there, and then we'll light the charcoal outside the firebox so that we can get it going. You can see the paraffin. Push it into the firebox. That will immediately ignite the pre-laid charcoal that you've got inside there sitting on top of the grate, and then you'll see that we have an electric fan sitting in the top of the chimney connected just to a car battery, 12-volt battery, and we switch that on and that pulls the fire through the right route so that the fire will go through the boiler rather than coming out of the fire hole door onto the footplate. We can just keep building that fire up with charcoal and ultimately onto anthracite beans, which is a high temperature, clean burning fuel. It won't light straight off the bat, which is why you have to start with the charcoal to get a warm bed there. But once you've got that warm bed and you're onto the coal, really you can see you get quite a bit of heat, and it builds the pressure up. Round about 30 or 40 pounds per square inch is when you can remove the fan from the top and then operate the steam blower, which is this little valve behind the chimney, and that blows a jet of steam up the chimney, and therefore now the steam engine is self-sufficient. It's providing its own drafting the right direction. It does that because this front area in black on an engine is called the smoke box, and essentially that's an area at the front that when a draft goes up the chimney it becomes a vacuum. It pulls a vacuum through a Venturi effect in that smoke box at the front, which drags all the air and the fire up those tubes and makes the fire burn hot, as you just saw. The pressures are all the way up to 90 there now, which means that the safety valves will be going off. They're here and they're controlled by this spring in the centre operating over the lever at the top, pushing down a valve in each one of those. You can see they're both lifting at 90 psi, and that was part of the steam test that we also did to make sure that the locomotive was safe. You can see here the engine starting to tick over now. It'll tick over anywhere from about 20 psi probably, but that was right up at working pressure. So this is how to put water in. Turn the water on for the injector, and that allows the water to dribble through the injector. Then the steam valve that you saw us operating earlier, turn it on, the water gets faster. Trim the water flow back and you'll see it goes dry and makes a little chirping sound that shows that it's actually sucking a little air as well as the water, but putting water into the boiler there. So that's the injector. Turning it off is exactly the opposite operation. So the steam supply is turned off first, and then the water is turned off afterwards. Now this engine has a crankshaft pump on it as well for pumping the water. This little lever here opens a little hole effectively in the top of the pump cylinder to allow the air to be pushed out. It's a priming valve, so when you see it open you can see the water squirting out through the copper pipe. Once primed, the pump is constantly pumping water from the bunker tank through this bypass valve back into the bunker tank. If you close the bypass valve, it can no longer get through there, and it takes the next path of least resistance through this non-return clack valve on the side of the boiler, feeding the boiler with more water. Next to the water lifter hose, this is the way that full-size traction engines would have got water as they were out and about on the move. They drop the hose into a lake or a river, turn on the steam valve, which blasts a jet of steam through a venturi, and that creates suction down the pipe, sucking the water up to fill, in this case, the belly tanks. You can also fill manually through this little flap, but either way is fine, and certainly the water lifter hose is a nice trick.
Okay.
Take a moment here to just point out some of the oiling spots. That's the crankshaft oiling points. There's one tucked away inside there on the gear. Those two are the eccentrics for forward and reverse. This is the big end, which has an unscrew cap on it. Essentially, it's any part that's moving and rubbing that needs to be lubricated. The other big end, the other eccentrics have got little oil pots on them. And then moving on again to the crankshaft oiling points. Here you can see oiling up the motion bracket at the front. This is for the crosshead and the slide bars. Again, anywhere that there's a little oiling pot, and also, as you can see here, anywhere where something slides, any surfaces that slide. This is slide way oil, which is a machine tool oil. It's designed to work at relatively cold temperatures, and as you can see, these are all the points on the locomotive that are external and therefore not subject to any degree of intense heat. There's a couple of more oil pots down here hidden on the footplate for doing the shafts and the axle that go across. There's one there with a little lid on it that you can get into, just to make sure that it's all oiled and lubricated. Again, it's a slideway oil rather than any particular thick oil, because nothing's running at any significant temperature here. It's all more or less running at a slightly warm version of atmospheric temperature. And a slightly different angle here, you can see the expansion links, which have a die block that slides up and down inside them. They have little holes on the top, but this is an example where there isn't really a pot. There's just pins and moving and sliding surfaces that it's a good idea to squirt some oil in there. A little bit here as well on the water pump shaft, just to make sure that that stays lubricated is a good idea. There's one more point. This is the steam oil. This is where you use thick oil designed to work at a higher temperature, because this is a mechanical pump that every time the flywheel goes round, it pumps a little bit of thicker steam oil directly into the cylinder and the valves. Onto the controls now. That was Mark operating the regulator. This is the gears, so push the gear stop in and move the gear selector arm across, and you'll see that engages the littlest gear there from the top on the end of the crankshaft, and that engages with effectively the biggest gear behind the wheel. So it means that the engine, the crankshaft and flywheel, is going relatively fast, but the big gear and the wheel is moving relatively slow, so that's effectively the slow gear. Disengage the pin, move the gear stop across to the other stop, and then move the gear selector in again. You might have to wiggle the flywheel around a little bit, and that engages the medium-sized gear on the end of the crankshaft in with another medium-sized gear behind the wheel. Of course, the ratios are different. For the same revolutions of the flywheel, the driving wheels go faster. Next one, disengage that gear and move round to the back now, where you saw my finger was, and there's another gear stop on the other side, which allows you to move in the large diameter wheel across. This is the third gear, and this is the fastest gear. This is obviously a large gear on the crankshaft onto a smaller gear on the wheel, which when you see it locked into place and moving, you'll see that for relatively few revolutions of the flywheel, the driving wheel is moving extremely fast. So that's really fast on the road. You'll see that later in this film actually being used in the car park. Reverse, obviously, self-explanatory, and back into forwards. Back to in steam again here. Finn putting a few more loads of anthracite beans on the fire so we can actually run it in the yard. It's quite tricky to drive the engine once the roof's back on again, and you'll have noticed in this video that the roof's been off and on for the purposes of explaining. The roof comes off relatively quickly, takes about 5-10 minutes with about 20 little nuts and bolts. But as you see, it's not necessary. It can be driven, even if it's a little bit fiddly and you've got to know where all the levers are, so you don't get your fingers trapped in any of the moving bits. When you finish playing, it's the reverse process of what we did at the very beginning. So this is removing the damper arm so that you're freeing up the ash pan on the bottom. Pull the pin out and the ash pan will drop to the floor. The grate might need a wiggle, but essentially the fire will drop onto the floor and you can roll the engine forward so that the rubber tyres don't accidentally get melted by the hot coals. This is the blowdown. You remember at the beginning we filled the boiler full of cold water here. With about 60 psi left in the boiler, it's a good idea to blow down every time. The more steam you boil off, the more concentrated the saltiness of the water in the boiler gets. So again, just to avoid limescale, great idea to blow it down. This is a drain plug on the bottom of the water tank. Particularly in the cold weather, it's important not to leave any water in it, so we're draining out the water in the belly tanks and the bunker tank here. There we go. Thanks ever so much for watching. I hope you found it interesting.